Welcome, MCTers. Day 45. This is our second day on factoring, and we're going to see some strange patterns today. Uh, Hopefully, it'll all go well. Some stuff is review, like the 3-minute review, and then some stuff will be brand new techniques, and those will be fun. So let's get into it. Expand, collect terms if necessary. Expanding's easy, right? Just multiply everything by everything. But there's a special point here, right? The special point is when I collect like terms, 5x and minus x in the middle, I end up with, I made a mistake there, didn't I? You see that? That was a minus 25. I end up with x squared, and then the middle term cancels out, and I'm left with minus 25. Similarly, over here, when I expand everything times everything, i's and j's, middle terms cancel out, and I'm left with an interesting pattern, isn't it? And this is the pattern that we're starting with today. We're asked to factor these, and I'm gonna pretend that we didn't do that. I'm gonna pretend this isn't review, and I'm gonna treat this like a normal simple trinomial. That one's a hard trinomial. This is two numbers that multiply to get negative 36, and the middle term isn't there. It adds to get 0. So what numbers multiply to get negative 36 and add to get 0? Well, minus 6 and 6. So this is y minus 6, y plus 6. Oh, yeah, okay, I'm remembering this pattern now. That's good. This one, how do I want to do this one? Well, maybe I'll do it box method. First term is 4d squared. Second term is 81f, negative 81f squared. And I want numbers that multiply to get, well, whatever 4 times 81 is. Multiply to get 324. And add to get, what's the middle term? 0. So what are some numbers that multiply to get to be 324? Well, I have to get out the old calculator. It's going to be the square root of that, I think, as long as I did that correctly. Probably 18, I'll bet. Look at all that mess. Square root 324. Yeah, 18. One's positive and one's negative, so they'll even out. And the middle term here, well, what's the middle term? It's kind of weird. I need a D and an F. 18, D and F. And if I factor up, I get 2D. I factor up, I get negative 9F. Factor across, I get 2D. Factor across, I get, oh, positive 9F. And there are my factors. Do you see and remember the pattern? This first term is just the square root of that first term. That second term is the square root of that second term. And the second bracket is exactly the same with the opposite sign. That's the difference of square patterns, and that's what we're up to today. Now notice that the picture here, although we could have used our previous day work to factor some expressions, it's often easier to look for patterns. So I played like a dummy and did it old way, but once we know this pattern, it's pretty easy. This pattern's wrong, by the way. This isn't what we want to find at all. It's actually, this is the pattern. We're going to have something squared, subtract some other thing squared. And I use shapes instead of letters, just because, you know, it doesn't have to be a letter. It doesn't have to be a number. These things can be anything, shapes. And I can still see the pattern. When I've got this difference of squares, something squared minus some, the first term is the first thing square rooted. The second thing is the second term square rooted, which is just a square in this one. And the second bracket is exactly the same thing, right? And then they have opposite signs, right? The middle term would cancel out when I expanded that. This is the difference of square patterns. And so for this one, how do I factor this? Well, I can identify that both of these I can take the square root of, so I know it's a difference of squares. B minus 4, B plus 4. I don't have to do any number games. I recognize the pattern. That's it. This one I can see I can take the square root of both things. Square root of 25v squared is 5v. The square root of w to the exponent 4, I need square root of this whole thing. This is what I'm thinking. Well, that's w squared times w squared, isn't it? That's what take the square root. Difference of square patterns. And these are pretty straightforward. Now, we'll actually be able to use the idea of a difference of squares to factor some pretty neat expressions. As we'll see later, the algebra today gets pretty involved. In fact, anything in this form can be factored as a difference of squares. So the idea here is, you know, this is something squared subtract something else squared. Doesn't matter what it is, I can still factor it as a difference of squares. Well, what's the square root of the first term? Well, that's going to be the square root of the first term is just a plus b, right? Don't worry about the squared. And then the second term is square. Well, that's c plus d bracket. And then the second bracket is exactly the same thing, right? Now, can you see how that's circle and that's square, that's circle and that's square? And I'm just going to put opposite signs in between them. Now, this looks pretty shoddy with all these brackets all over the place. I'm going to remove the brackets and then get an expression that looks pretty nice. Luckily, we won't have to actually expand this. There. Nice. This idea of patterns, right? Where this would happen to be, this happened to be a bracket. It could be anything in there. It could be a series of brackets. It could be brackets and numbers. It could be just as simple as a plain old 1, because 1 I know can be written as something squared. Well, this idea of looking for a pattern allows us to factor some pretty cool expressions. Like this one has an exponent 4 on it, right? We have never factored anything sort of this difficult, except for maybe if it was this. Yeah, whoops, if that's a minus, that's got to be a minus, because then it would be a difference of squares, right? That's not bad. Fine. But this one's not. Something weird's going on here. But can you see how this kinda looks like this? This is what's called quadratic form. It's quadratic form. And here where the v squared is, I've put an a in its placeholder. I said, instead of having v squared, which makes it an exponent 4, let's just put a. And notice that a squared, v squared is v to the exponent 4. So I haven't cheated or anything like that there. This does work. Well, this one's not hard. This is a simple trinomial now, right? Numbers that multiply to get 36 and add to get negative 13. Multiply to get 36. Add to get negative 13. What is it? Negative 9 and negative 4. So I got a minus 9 and a minus 4. You say, well, hang on, you're not done. We started with v. You just put a in as a placeholder. Well, let's put v back in then. A is the same as v squared, so put v back in. And now you see I got two sets of differences of squares. This one factors into v minus 3, v plus 3. That's that one. This one here is going to factor into v minus 2 and v plus 2. Four factors, just like we expected. When we're talking about polynomial graphs, polynomial functions, we expected to have four brackets if we could break it up, and that was the case. This one looks a bit strange, but notice that where the a is another expression. I could think of a taking the place of x squared plus 2x. So this is quadratic form again. And again, I'm just using the a for a little placeholder. It's just making it a little bit simpler. Well, I'm going to factor that. Numbers that multiply to get 24 and add to get negative 11. Signs are the same, both negatives, negative 3 and negative 8 give me negative 11. So this is a minus 8, a minus 3. And so now if I want to actually answer the question I was asked to, I put that back in for a. And now I've got I've just factored two quadratics. And those each are their own number puzzle, right? Multiply to get negative 8, add to get positive 2, 4 and negative 2 work, yep. So this is x minus 4 and x plus 4 and x minus 2. And this one is yet another one. Fantastic questions. This feels like grade 12 work, not grade 10 work. This is better. 3 and negative 1. 3 and negative 1. That adds to get 2. Yep, those are my numbers. Wow. What a question. Great. Now, all this factoring doesn't, it's kind of weird. It doesn't feel like it fits in very well, does it? And I know it's getting late, but I'm going to finish this off in one video. I got about another 5 minutes to go here. So just talking about how the factoring doesn't fit in, because where we started in this lesson was, or in this unit, was graphing stuff. You know, we were graphing stuff like this, and we were talking about starts and ends and zeros and bounces. We're talking about graphs, and where did that go? Because once we could see a graph, we knew a whole bunch of stuff about the expression as well. So that's what we're getting back to. One of the goals behind factoring is so we can graph functions more easily. Well, notice how this is the one from example 4a. Right? It's exactly the same question. Where'd it go? Right there. Except for I have v's instead of x's. So I could write that that expression as x minus 3, x plus 3, x minus 2, and x plus 2, right? That factors into there from all of our work in the last example. Well, that's pretty awesome, because I can see this is a degree 4. Leading coefficient's positive, so I know it starts high and ends high. And then I got all these x-intercepts. X-intercept at 3, minus 3, 2, and minus 2. And geez, that's going to be enough for me to do a pretty decent sketch of this thing, right? So minus 3, minus 2, and then over here 2 and 3. All of these are slash roots. I start high and end high. It's going to do something like this, right? Slash, 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 slash. And look, this is an even function, isn't it? Look at even, even. This is an even expression. We like having an extra point, and normally we'll pick the y-intercept if it wasn't a root. When I pick x is 0, y is 36. And so that's the 0.036 right there. And that's a real nice sketch. And it was just that fast because we knew how to factor it. This one, how do we factor this? Well, maybe we'll try one of our factoring techniques from this week. Notice I don't see any difference of squares, and I don't see that it's quadratic form, but what I do see is it looks like I can do some grouping. If I took out x squared from the first part, and I took out a -4 from the second part, see that -4 goes into that, and -4 goes into 20 minus 5 times, and then I have a common factor that's left over. This is grouping. Turn that frown upside down. Whoops, hang on. Right, the common factor out front, what's left inside the brackets is x squared minus 4. There's another difference of squares, right? X minus 2 and x plus 2. So real quick, this is a cubic. The degree's 3. Leading coefficient's positive, so it starts low and ends high. And then I got those as x-intercepts. 5, -2, and 2. This is good. All this factoring actually is helping me do graphs, which is what the whole point of this chapter was. -2 is there, 2 is over there, we'll say. And remember, we don't really care about the y-axis. Starts low and ends high. Starts low, ends high. One point on this bad boy just to get some scale. When I put 0 in there, I get 20. And that's pretty nice, right? 0 in there, and then there's my y-intercept 20. And there's a pretty good sketch of a function without doing too much extra work. Now, part of the homework, there's a couple there that are like this last example where I've asked you to graph. Okay, so check, there's no answers. It's not part of the textbook. Check those on the graphing calculator. And to set us up here, like, what happens? What happens if it doesn't factor like this? If when I try and do grouping, I'm left with something different in the brackets, right? This doesn't work. It doesn't factor. That is a sad face, and there's going to be a lot of expressions like that that don't work out nice. And this idea of factoring is going to be the next couple of days. How do I factor these expressions that don't factor with one of these new techniques? And that's the next couple of days. Okay, well, have fun with your homework. Sorry it was a long video, but this is the only one. Thanks for stopping by, and stay classy.